This is the last lecture in our geometry introduction, and we're going to look at geometry in 3 dimensions. So we had simple closed curves. Now we're going to have what we call a simple closed surface, which has one interior, which means there are no holes, and it's going to be considered to be hollow. So it's not filled up with anything. You could theoretically pour something into it if it had a hole. These two figures are not simple and closed because they have a hole in them. And I have 2 separate interiors in the one on the right. A sphere is a set of all points that are a given distance from a center, and that would be things like a basketball. And really, with your kids, a lot of times they will say that like a basketball is a circle and not a sphere. So work on making them recognize the difference in 2 dimensions and 3 dimensions with that. A solid is going to be a set of all points on a simple closed surface together with all interior points. And a polyhedron is going to be a closed surface made up of polygon faces. So think like a box. And each one has a vertice, which is the corner, and an edge, which is like the box edges. Here are some examples of polyhedra, and then some examples that are not going to be polyhedra. A prism is going to be a polyhedron where there are 2 congruent faces, typically the top and the bottom, and they're going to be parallel planes, and the other faces are going to be bounded by some type of parallelogram, whether it's a rectangle, whether it's a square, whether it's a rhombus. A right prism means that the lateral faces are perpendicular, okay? So that means the face that is connected to the top or the bottom. An oblique prism is when the lateral faces are not perpendicular and they tend to kind of lean. You see that? They lean a little bit because they don't have those nice 90-degree angles. A pyramid is going to be a polyhedron determined by a polygon and some point not on the plane. So imagine this to be 3-dimensional with 3 triangle faces and a triangle base. In a right pyramid, the faces are going to be congruent isosceles triangles. So that's going to be what determines you to have a right pyramid. A truncated polyhedron is going to be when one or more corners of the polyhedron is removed by an intersecting plane or planes, and so it's kind of truncated it. So like I cut a corner off of a box. You know, if you just cut the corner, like it has the truncated cube, you'll kind of see that it's been kind of cut off. A convex polyhedron is going to be a polyhedron in which a segment connecting any 2 points in the interior is also in the interior. Regular is what we always use for congruency statements. So if it's regular, the faces are congruent, so equal, they're the same size. So I have the cube, the tetrahedron, and the octahedron are all regular in this image because all the triangles are equal in the tetrahedron, all the triangles are congruent in the octahedron, and all the faces of a cube are also congruent. So when I say regular, think congruent. Here are some other examples of congruent polyhedrons as well. Here, I've taken the time to put some of the interesting things here with each of the polygons and how they're related to the polyhedron that is formed by it. Next would be if you imagine taking your Amazon box, because we all order off of Amazon now, right? If I cut it open, so I don't know if you guys break boxes down to put them into the trash can, but imagine if you're breaking a box down and that you cut all but one of those edges off and you laid it flat. That would be an example of a net. A cylinder is going to be like a can of soup. A cone is going to be like an ice cream cone. So we do typically use that vocabulary in our everyday life.